This is your video explanation for how to graph lines from equations, and we're also going to talk about slope and what slope means. So the first thing we're going to do is practice graphing this equation, y equals 3x minus 1. And before we begin, we want to just remind ourselves that this is an equation written in the form y equals mx plus b. When an equation is written as y equals mx plus b, we know that the m number represents the slope, and the b number represents the y-intercept. So when we are attempting to graph from an equation, the first thing we do is look at the value of b. So in this first example, b is equal to -1. So we're going to start by graphing that. b equals -1 means that the y-intercept is -1. When we come over to our graph, the first thing I'm going to do is label the axes, and then look at the y-axis, which is the long one, the high one, and we are going to go down 1. So that is our b equals -1. So y-intercept of -1. The second thing we're going to do is look at this m value. So for this first equation, m is equal to 3. And we prefer slope to be written as a fraction. So if we want to write 3 as a fraction that is equal to 3, we have to make a denominator, and the denominator we put there is 1. So our rise is going to be 3 and our run is going to be 1. So from this y-intercept of -1, we're going to go up 3 units and over 1 unit and put a dot. Once you have 2 dots, that's enough to draw a line. So you're going to connect them and label it with the equation. Y equals 3x minus 1. We're now going to follow the exact same steps to graph this second equation. So to review, we start by identifying the b value, and that is our y-intercept. So if we were to graph that, we're going to graph it right here, y-intercept of b equals 2. Then we are going to look at the m value, and in this case, it's also 3, which we write as 3 over 1. So from that green dot, we're going to go up 3, so a rise of 3, a run of 1, put a second dot, connect them, and label it with our equation. And you can see from these two lines that they share the same slope. So the slope is the same. We already said that m was equal to 3. What do you notice about the slopes, both in the graph and in the equation? Well, the slopes, as we said here, the slopes are both the same. M equals 3, and if you look at the graph, they both look like that they're exactly the same amount of steepness as the other one. So their slopes are the same. Very quickly, we're going to do one more example with 2 lines. We're going to graph y equals -2x plus 1. So again, the first thing we do is graph the y-intercept. Of +1. And then we look at the slope, and in this case, slope is equal to -2. We write it as a fraction, so from that y-intercept, we're going to go down 2 and over 1. Put a dot, draw our line. Oh, I don't like that. Draw our line. Y equals -2x plus 1. Then we are going to graph the second line, y equals -2x minus 3. Again, we start with the b value of -3, just right there. We have the same m as the last one, -2 over 1, so we go down to rise of -2 over 1, run of 1. Draw our second dot, connect the two dots, y equals -2x minus 3. So we can see again in this example that the two equations had the same slope. In both cases, the slope was -2. And again, we see that they have the same slope, so we can sort of refer to that answer. And what word best describes each pair of lines? If you look at the graph, the lines have the same slope, and it turns out that when that's the case, they are parallel. And the last question says what you notice about the y-intercepts of each line. So the y-intercepts tell you where the line crosses the y-axis. So if they're parallel, it doesn't matter where the y-intercepts are. It just tells you how far up and down they're going to move. So the y-intercepts are in different places. And that has nothing to do with them being parallel or not. And that's the end. Thanks for watching.